Very good afternoon to all of you B.Sc first year students of analytical chemistry. In last lecture we have learned about the classification of quantitative analysis on the basis of property and parameter measure. In today's lecture we are going to learn steps in typical quantitative analysis. Let's start with the steps in typical quantitative analysis. So, steps in typical quantitative analysis. Following steps are generally followed in typical quantitative analysis during the what when you are going to analyze the sample quantitatively, then it is need to go through all these steps. So, first step is the definition of the problem. Then, if you are going to analyze any sample, then it will be what it is customary that you must know about the what is the aim of analysis, what you want to analyze, what type of constituent from the given sample you want to analyze. So first one is the definition of the problem, what type of the analysis is that. The first step in the solving analytical problems is the identification of the problem. Only by clearly identifying the problem can one devise a logical path towards its solution. So, which type of constituent, which type of problem you have tackled in the analysis is what firstly fix that type of problem, then uh, develop uh, for the development of the solution for the problem, then you must able to develop a logical path towards the solution. So many questions should be asked. For example, what kind of sample is it, which type of sample is there, inorganic and organic, whether it is organic origin or whether it is in organic origin, what information is being sought, you have what type of the information and what type of information you want to collect from this, what accuracy and precision is demanded for the analysis, what type of the accuracy is required, what type of the precision is required, what correctness is required in the analysis, is the sample large or small, what is the size of sample. You have already classified the types of quantitative analysis on the basis of size, property and parameter. So it is important to know about the sample size. So what type of the sample size, sample is large or sample is small. So are standards available for that? For analyzing anyone, you compare any sample, you compare with the standards. You know about the standard quantity, standard value for that, then any standards available for that, it is what need to be know. So how many samples have to be analyzed, what type of, how many types of the samples you have chosen for the analysis, what is the cost of analysis. When we are going to analyze any sample, then what type of expense you will have, it is customary to know. Then are suitable equipment and personnel available for that purpose. You have the required personnel as well as the what equipment for that analysis is to be known. The answer for the above type of question will frequently dictate how the necessary steps of the total analysis process should be taken. So answer for all these problems, all these questions, the solution for that is when we get this solution, when we know about the how many steps or which type of steps followed in the analysis. So this is about the first step, the definition of the problem. Second step, choosing an analytical method, which type of method you choose for the analysis. So important factors are considered in choosing the analytical methods. During choosing the analytical method, it is easy less time consuming, it is less expensive. This type of the method is choose. So this is very important step in the quantitative analysis. These are concentration range, required accuracy and sensitivity, selectivity, time requirement and cost of the analysis. As I have already told that uh, most of the factors affects the uh, which analytical method choose for the analysis. So such factors are concentration range are there, but which type of the concentration is required, what expecting, what type of accuracy required, what type of the sensitivity and selectivity is there, and most important is the time and cost requirement for the analysis. So these are most important factor. The second step, and the third step, the concentration range. For that, for the macro analysis, the sample size is macro. For macro samples, the substance to be determined is present as a major constituent on a percent basis. So what is the requirement? If you taking a macro sample, then which constituent you are going to analyze what the major constituent, most part of this sample contains constituent is a major uh, constituent on a percentage basis. So in contrast, for the micro and smaller samples, the substances is at trace level at less than percent concentration. So when we use the micro samples or smaller than the micro samples, the ultra micro or semi micro are there, then such a type of sample we require small size of the sample, and so uh, the minor constituent or minor um, what the minor constituent and the percentage basis may be taken. So what according to that is what the trace amount should be taken. Consequently, analytical method can be divided according to the what the suitability to the size of the sample. So according to sample, we have already learned that the classification depending upon the size, that is what the micro, macro, semi micro, ultra micro, depending upon the what the sample size. In general, chemical methods tend to be best for the determination of macro amounts and instrumental method for the trace amount. So what type of the instrument required for the different types of the analysis, that if you are going to analyze the macro samples, then simple analytical methods are used, laboratory methods, and if you are what going to measure the uh, trace amounts, then instrumental method is what the perfect one. The ability to match the method to the optimum sample size is usually gained through experience and awareness of the different methods. So it is what the which type of the analytical method are chosen for the analysis, it depend upon the experience also, because the person who is what analyzing the sample, he is what most experienced, then it easily what sorry he is able to uh, choose what he is able to select the appropriate method for the analysis. So fourth one is the sensitivity and accuracy. Sensitivity, as it applies to an analytical method, corresponds to minimum concentration or lowest concentration of the substance that is detectable with a specified reliability or sensitivity. Sensitivity is very important because the method is sensitive means what it is what able to analyze the sample at a minimum concentration. So different analytical methods will provide different sensitivity, and the one chosen will depends on the sensitivity that is required to solve a particular problem. So it is depending upon to what type of the analysis there, and what type of method is chosen, and sensitivity is also varies with the different types of methods. So the smaller the sample, for example trace level, the more sensitive the method must be used. If the sample size is very less, then most sensitive method is to be used. So what is about the accuracy? Accuracy refers to the correctness of the result achieved by the analytical methods. What accuracy, it means what the correctness. So which type of method, how this method is correct. As the sensitivity varies among the methods, so does the accuracy. In practice, the analytical chemist will choose method that provide the required level of accuracy. So, what type of method is there? What type of accuracy is there? So, if you require the what you are going to analyze the small sample size, then you require the more accuracy and the more sensitive method is there. So, in order to achieve the necessary accuracy, higher costs and expensive consumption of time, equipment, and personnel may be required. So, this is always what indirectly it is that if you are going to analyze the sample correctly or with accuracy, greater accuracy and sensitivity, then it may requires more cost. Higher cost is there, time consuming is there, and equipment required, personnel required is also what may be higher or what the sensitive one. So this is about the sensitivity and accuracy. Then what is the selectivity? It is selectivity is independent, undoubtedly depending upon the what, dependent upon the selectivity is there. Sensitivity is there. So selectivity is an indication of the preference that a particular method shows for one substance over another. So we are going to analyze the ultra micro samples. Then if you have the macro analysis, if you have the semi micro analysis, test analysis, instrumental method, then it is necessary to choose which type of the method is useful for the analysis. So the more complex the sample, the more selective and what the chosen analytical method must be if one component is to be determined in the presence of the rest. So whatever the complexity is there for the analysis, then that type of the selective and sensitive method is what required or it's to be chosen for the analysis. If you want to what analyze one constituent from the any sample from in presence of other samples, then it is a complex method, so it requires some most selective method. So specificity another term that is often used is the specificity. What type of the specific method used for the specific constituent analysis, whereas selectivity shows a preference. Specificity in analytical method implies specific response. So what is the difference between specificity and selectivity? Selectivity having the alternative, but specificity has no alternative. It is what the implies the specific response. So in general, analytical methods are not completely specific towards an individual component, so they are not specific towards the individual that is what the component which we will have to determine. Then next one is the time and cost. The time and cost often go hand in hand and usually are a reflection of the equipment, personnel, and space required to the complete determination. So whatever the time increases, large time required, and cost also is the large, and what the personnel required for that and equipment required is also large. So the number of samples will also influence the choice of method. So what number of sample we will have to analyze, then it also implies the or it also influences the choice of the method. If there are many similar samples, such as in quality control, provision for automation becomes feasible. So what happen if you want to what they analyze number of samples, same samples within the one QC is there, so it is what feasible for the analysis, and what it is the less time consuming and cost consuming. So next one is sampling. On the defining the problem of analysis, an analytical chemist must decide how to obtain representative sample for the analysis. What type of the what is mean by the representative sample? Mean what the sample which contains all the constituent in the proportion. So The term representative implies that the sample chosen for analysis will reflect the entire body from which it comes. So I have already explained this term. That is what the each pinch of the sample represent all the constituent in the uh, present in that sample. So consider the iron ore in the birch. How does an analytical chemist choose an ore sample wishing a few grams at most that will contain the same percentage of iron as the several tons of iron ore in the birch? So the iron ore problem deals with, so what is the example is given, that is what the how homogeneous sample is there. If we taken the iron ore, that is hematite ore from the birds, and with the same proportion, if you take a pinch of ore, then it contains that amount of iron, which contains a tons of what the which is exactly the proportion in the tons of wood. So this is what the homogeneous samples, those with the composition that is not uniform. So homogeneous uh, composition, homogeneous samples, those with composition that is not uniform one. So however, sometimes the samples are homogeneous but the system itself fluctuates, as is the case in most environmental analysis. So what happen if you are talking about the homogeneous means what the it is the one phase mixture, but the composition is not uniform one. So it is what the environment, in most cases in the environmental analysis it fluctuates, the percentage of the given constituent will fluctuate. For example, to measure the wastewater effluent in leaving a company, it would be useless to base your analysis simply on sample gathered when the factory was shut down or opening at the reduced capacity. Also, it is what not customary that the all the samples, all the water, that is what the wastewater, that is nothing but effluent, industrial effluent means what the wastewater, water released from the industry, they contain same amount of the constituent. It is not able to what tell that the all samples with the having same proportion. So it is varies with the uh, operating time, or it is opening or the shutdown of the industries. So even more difficult would be the deciding where and when to take a sample of air that would be representative of large areas such as Bombay Basin. So if you are analyzing the pollution in the air or component in the air, so it's not easy to know tell whether the homogeneous mixture from the air is what collected. So air quality generally or better yet monitored continuously many sampling stations at the various elevations. So it is the what the need to collect the sample at various elevation and various places. Even then, it might still be impossible to determine the definite weather and air quality in the city because it is get changes. So now better or worse than it is was the previous year. So what is it is better to what collect the samples in various stations and sampling stations and what analyze the air. So next one is the dissolving the samples. Solid samples must be given special treatment to effect their solution. So most analyses are performed on the solution of the sample. The solvent should dissolve the entire sample rapidly. The condition of dissolving should be sufficiently mild so that loss of the analyte cannot be occurred. So, what is the condition is that the sample is soluble, completely soluble in the given solvent. Such a type of the solvent is the what chosen for the what avoiding the what the uh, sample loss, or what the some solvent should be dissolved when entire sample ready. So condition in dissolving should be sufficiently what the mild so that the loss of the analyte cannot be occur. So that is the purpose. Unfortunately, many material that must be analyzed are insoluble in common solvent. So Many materials are not soluble in all types of solvents. Some common solvent. High molecular weight polymers are specimens of animal tissues. Such type of the samples not soluble, completely soluble in solvent. So conversion of the analyte in such material into soluble form can be difficult and time consuming. So it is not easy to what make these samples soluble. So the next one is eliminating interferences. Interferences means foreign substances. So before an physical or chemical measurement can be made to determine the amount of analyte in the solution of the sample, it is usually necessary to the solve the problem of interferences, because the impurities in the sample or interferences in the sample what affects the result for the analysis. So the substance that prevents the direct measurement of the analyte concentration are called as interferences. So what is interferences? The substance that prevents the direct measurement of the analyte concentration. So it is what prevent the direct measurement of the analyte concentration is called as what interference. It is important to separate the interferences prior to that final measurement. So firstly, first step for the analysis is to what remove the interferences during the what the analysis. So this method involves the physical separation of the analyte from the interferences. Suppose that one wishes to determine magnesium sample which also contains iron third iron, and the magnesium is to be precipitated as the oxalate. The iron will interference since it also precipitates with the oxalate. The iron can be precipitated as hydroxide using ammonia at pH 8.5. The magnesium is not precipitated at this pH. So and hence its interferences is removed. What is the physical separation? Means what this interferences is removed by means of physical means, and for example is given for if you any one ore contains a magnesium and iron, and if you are going to analyze the magnesium, and if you want to what remove the interferences, then if you take the example, that is what the it what if you remove the interferences by means of the precipitation, that is what the oxalate complex formation, then treat the solution of that ore with the oxalate. Then if you take a simple condition, then the iron also precipitate and magnesium also precipitate as oxalate. But if you take this precipitation at the pH with the hydroxide using ammonia at the pH of 8.5, then only the iron will get what precipitated as oxalate, and another magnesium is not precipitated in this pH, and hence the interferences is removed. In a gravimetric analysis, the analyte is what physically separated from all other components of the sample as from the solvent. For example, the chloride in a sample may be determined by precipitation of silver chloride, which is then filtered, dried, and weighed. Precipitation is the most widely used technique for the separating analyte from the interferences. So, other important methods includes electrolysis as well as solvent extraction. All these are methods used for the what the removing the interferences. Then calibration and measurement. So all the analytical results depend on the final measurement, that is what x of physical property of analyte. This property must vary in a known and reproducible way with the concentration C of the analyte. Often the physical property measured is directly proportional to the concentration, that is what Ca is equal to Kx. Then where K is the proportionality constant, an analytical method required the empirical determination of K with chemical standard for which Ca is known and itself as the calibration. So what is the most important steps in the analysis is about the calibration of method. So calibration of instrument. Next one is evaluating results and estimating their reliability. That is the final step of the quantitative analysis. The consumption of analyte concentration from experimental data is sorry The computation of an analytical data, computation of an analyte concentration from experimental data is ordinarily a simple and straightforward task. So, how will you compute the analyte concentration and experimental data? It is what easy but straightforward. But such computation are based on the raw experimental data collected. What the measurement steps, first measurement step, the stoichiometry of the chemical reaction of interest, and without an estimate of their reliability, the experimenter must provide some measure of the uncertainties associated with the computed results in the data are to have any values. Mixed statistical analysis may be used to determine the precision required of the analytical techniques and the number of samples that must be analyzed to answer the question to within the specified limit of the uncertainty. It means what? The results are uncertain. So it is not the 100% that result that is confirmed result, but analyst must show result in the uncertainty, some uncertainties, or in the statistical analysis, or what some reliability. So this is about the steps followed in the steps in typical quantitative analysis. So if you have any queries regarding this topic, please comment the your questions in the YouTube comment box. I will try to answer. Thank you. Thanks a lot. Have a nice day.